Solve the quadratic equation, here we go, by using the quadratic formula. That's x squared minus 3x equals 40. Once again, solve the quadratic equation by using the quadratic formula. That's for x squared minus 3x equals 40. So let's take a look at it. Let's see what we've got going on with this thing. First of all, notice we have the problem written, and you're going like, okay, Ernie, it's got x squared. Could we do factoring? Sure, we could set this thing equal to 0 and factor, but the question didn't ask for us to do that, right? It says, let's go to the quadratic formula. However, when we use the quadratic formula, remember, we have to have it in the form that is also equal to 0. Now, yesterday we had a completing the square problem, where you basically took this number here and added the same thing to both sides. That's completing the square. On completing a square, you have to have just the x squared and the x value, linear term, so to speak, there, and to find what's missing. This time, we're going to subtract 40 and start off, okay? So this is how it works with the quadratic formula. We got x squared minus 3x minus 40 equaling to 0. That's where we start. That's where we start. Now, at this point, folks, the whole point is, let's see, well, what is the whole point? Y'all keep saying, what is he doing? How about it? X equals opposite of b plus or minus a big old woofing radical. And we got b squared minus 4 times a times c over 2a, as I like to sing it, all right? And before this makes any sense, you're going like, well, I don't see an a, b, or c, Ernie. Well, we got to make that happen, all right? First of all, a is the number that is in front of the x squared. And in this problem, we have a 1. You don't see it, but we have a 1 there. So there's our start. A equals 1. I'm going to put them right over here. A equals 1. You look at b, there it is. B is a negative 3. That didn't change, okay? The only thing that really changed was this 40 came over to be negative, all right? So that's what we have to make sure c is equal to a negative 40. Now we're ready to work through this formula, all right? Those are 3 important little numbers there, all right? So let's see where we're going to go. You say, Ernie, we're going to use this formula. That's why they call it the quadratic formula. It will get us to x by itself. So let's see, the opposite of negative 3, that's going to give me 3 right there. Now, yes, folks, it says negative b, but it's the opposite of what we have. So we go positive with that. How about it? Plus or minus, what's going to happen here? Put a negative 3 in there and square it. Minus 4 times, it looks like a 1, and a negative 40. Woo, big numbers there. We're good. We're on Mathline, okay? We can handle this. All over 2 times 1. That part's easy. That part's easy, all right? So let's see where this conglomeration of numbers here is going to happen. By the way, we're going to pretend the big old radical is like a big old parentheses. So we're going to work down under here. We're going to do our exponent, then we're going to do our multiplication, and we'll add the results together. By the way, underneath here we've got a 2. That one is easy. All right, that part is easy. So we got 3 plus or minus, big old square root. Well, negative 3 squared is, negative 3 times negative 3 is 9. All right. And on this part down here, I've got a negative 4 times 1 times negative 40, which gives me 160. So again, my dear Aunt Sally is taking charge here. But yeah, let me remind you something here. This is like a big old parenthesis, that square root radical, all right? So, oh, by the way, it's all over 2. We can do that much. And basically, this is like a big bracket, what's above it, and then we'll do something with what's below it once we get to the final outcome here. So let's bring it over here. Let's see where this is going to take us. It's going to take us 3 plus or minus the square root of 169, which makes me happy. Y'all know why it makes me happy? It makes me happy very simply because it's a perfect square. 169 is a perfect square. It gives us 13. So this is going to be an easy one to figure out. It's going to be easy to figure out. Over 2 still. Don't lose that 2. Don't lose your 2. So you say, well, Ernie, what do we do with that? We're going to say 3 plus or minus 13. Put it over 2. Wow, we're going good here. So the options, there are 2 options. I could say 3 plus 13, which is going to give me 16 over 2, which equals 8. There's one of them right there. On the other side of the picture here, we've got one more run down here. How about it? We have 3 minus 13, which is going to give me negative 10. Put it over 2. We get negative 5. So there are our two solutions right there, 8 and negative 5. Wow, I'm almost out of room. Thank goodness I left me a little bit of space. We're going to check it, make sure they work. So we're going to take x squared minus 3x equals to 40. Back to our original. I'm going to bring it right there, okay? Bring it right back down there. And we're going to put our 8 squared in. That's 8 squared minus 3 times 8. And does it give us 40? Big question. Well, 8 squared is 64, and 64 minus 24 does equal 40, so that's good. Now let's take that same equation, let's play with the negative 5. We put negative 5 squared minus 3 times negative 5. Question is, do we get 40? And we already worked this one out, that gave us 40, so we've got to get 40 again. So negative 5 squared is positive, so it's going to be 25, positive 25, plus 15, and you see what I see? Everybody sees what I see? Checks. All right. So this is the checking part. This over here is the solving part. Woo!
For more math help, visit TNLearn.org.